by OneClass. Today we'll be going over a few math questions. These are mostly of the high school to university level questions we'll be covering. So just a little bit about myself. I'm a University of Waterloo graduate. I went there to study mechanical engineering. I graduated in 2018 and I've been working in the plastics industry for about 2 years now. My next thing is I'll be starting my master's degree at University of Toronto in January, so I'm really looking forward to that. Awesome. So let's get into it then. Okay. So the first question for today is how many seconds are in a 24-hour day? So to do this question, we'll need to know how do you convert seconds from minutes, minutes from hours, and then we need to know how many hours are in a day. So question 1, how many seconds are in a 24-hour day? So we know that one day corresponds to obviously 24 hours, and then 1 hour has 60 minutes, and then every minute has 60 seconds. So based on this, we need to know that we need to get from here to here to here and to finally 2 seconds. So the way we would do that is we would say 1 day times 24 hours per day times 60 minutes per hour times 60 seconds per minutes. So the reason I'm doing it this way is that you can see the units for each conversion, and then you can see them cancel out. So that way you know that the unit you're left with is the final unit, or is the unit for the answer. So in this case, you know here the days and the days cancel out, hours and hours cancel out, and then minutes and minutes cancel out. So final answer would be 24 times 60 times 60 seconds, which is also equal to, let me just quickly calculate that. So 24 times 60 times 60. So that's equal to 86,400 seconds. Okay, so 86,400 seconds. So that's the answer. The key takeaway from this question is the unit conversion portion and how we go ahead with it, and how we write that down. So I would really recommend having it in this fractional form where you write down where you started with and then write down the units for each conversion so you can see them progress through till you get the final unit which you're looking for. Okay, so let's look at the answer. So 1 hour 24 day, perfect. Yep, so this is all correct. The solution is correct. Okay, let's get into the next question. So commutative property of multiplication. So this is one of the key properties of multiplication. We use that very often. It can also be used as a trick almost, like, because sometimes students find it easier to multiply a certain number by another number. So for example, someone might be very familiar with the multiplication of 8, let's say, whether as opposed to a multiplication of another number, let's say 9. So if you have two numbers and if you can group them to get 8, you're winning that way. So the way I would explain this is commutative property essentially means that A times B times C is equals to A times B times C. So you can rearrange the multiplication of any number of expressions in any order and you'll still get the same answer. So if we go back to my example of, let's say, multiplying by a certain number, if I say my A is equals to 2, B equals to 4, and C equals to 6, for example. So here, let's say if I was computing this, so I could write this as 2 times 4 and then times 6, or I could write this as 2 times 4 times 6. Or there will be a third way as well, which we can write it as in terms of brackets, which is we'll keep the 4 out and then we'll say it's 6 times 2. So these are all equivalent. We can write it in any of these forms, but some people might be more familiar with the table for 8 or the multiplication for 8 as opposed to the multiplication of 24 in this case or 12 in this case. So this might be their preferred route, for example. So if we compute this, we would get 2 times 4 is 8 times 6, which is equals to 48. So the answer will be 48 in each case. It's just that we chose to do it this way. So again, multiplication is commutative, which means that you can rearrange the terms in any order and you would still get the same answer when you're multiplying them. Okay, so let's look at the answer here. I think simplification at work, it's the same commutative property. You might have to multiply numbers in different order to make the problem easy to solve, but your end result, your answer will not be the same, will be the same. So that's perfect. So here we are representing them in rows and columns. So if you look at this, you have 3 rows and 2 columns of oranges, but at the end of the day, you still have 6 oranges, regardless of if you arrange them like this or like this. So this is pretty good. It explains it very well. Okay. So the explanation is very detailed, and the answer is correct. Perfect. So let's jump right into the next question. For n equal to 6 rectangles with endpoints on the x-axis of a equal to 10 and b equal to 26, what is the width delta x for each rectangle? Okay, using the midpoint rule. Okay, so for question 3, we are given that we have 6 rectangles and they start from a equal to 10 to b equal to 26. So I'm just gonna draw that out here very roughly. So this is our x-axis. Let's say this is 10 and then this is 28. So between these, we don't know the height of the rectangles, but we just know that there are 6 of them. So let me see if I can do it through shape. Okay, so we have 6. So the first one, we have the second one, so or this is the first one. That's 2 rectangles so far. That's 3, 4, 5, and then 6. So, well, this 28, I guess, could probably move closer in that case. So I guess this point here is the 28. So what this diagram is trying to show is we have 6 rectangles. We don't really know what the heights are, but we know that they're all the same width. So all of these are delta x. Okay, so if we have 6 delta x's, we know that this length combined would be equal to delta x plus all the way to 6 delta x basically, correct? So from that we can say that this combined length of the rectangle is 6 delta x. Okay, and then we know that the length of this portion here on the x-axis would be, if we go 28 units from the x-axis and then we come back 10 units, that's essentially 28 minus 10, which is equal to 18 units. So these two are the same, so we can say 6 delta x is equals to 18, or we can say that delta x equal to 18 over 6, which is equal to 3. So all the widths of each of the rectangle is 3 in our case. There's also another way of doing it, which is so this is a bit incorrect. Yeah, never mind. This is the correct way of doing it. The solution here is a bit incorrect because delta 8 should be 18 in this case. Let me just write that down. Solution was noted as 8. Oh, it should have been 18. The final answer is correct. However, one of the step is incorrect. Okay, let's get into the next question. Okay, an isosceles triangle with a perimeter of 8 centimeters. Find a function that models its area in terms of the length of its base. Okay, this is a fun one. So what the question is asking us to do is, we have an isosceles triangle. Okay, let me just use my draw tool just to and that will hopefully help you understand what an isosceles triangle is as well. Okay, and perfect. So what an isosceles triangle is that it has two of its sides equal. So in generally we represent them by these two equal to signs on the sides. So if we have this as the triangle ABC, we say that AB equal to AC, so the lengths are equal. So that's the property of an isosceles triangle. In this question we're given that the perimeter is 8 centimeters and we need to find a function for the area in terms of the base, so BC. I'm gonna name these in a way so it's easier to represent. So I'm gonna call this side as S. This side will also be S because we know it's an isosceles triangle. And then BC I'm gonna call the base. Okay. So now we are given that the perimeter is 8. So the formula for the perimeter is nothing but the sum of all those sides. So we will get S plus B equal to A, or we can say 2S plus B equal to A. Now straight away the variable which we need to separate for is S because we want our final answer to be in terms of B. So if I get S from here, I can substitute it in the next step. So what I will do is I'm gonna move B to the other side and then divide the equation by 2. So it will be 8 minus B over 2, which is equal to S. Okay. So now we will write the formula for the area. Area is equals to half base into height. So for our given triangle, if I drop a line perpendicular which is equal to the height, we need to compute what this height would be. So when a median is dropped, this intersects this side into two equal halves. So we had said that this side is equal to B. So each of the half would be equal to B over 2. So now what we can say is to get the h we need to perform the Pythagoras theorem, and this side was s. So according to the Pythagoras theorem, if we have the square of the hypotenuse for a right angle triangle, that is, it will be equal to the sum of the squares of the two sides. So it will be equal to h square plus b over 2 squared. So from this equation we need to separate for h, so we can substitute it in the equation for the area. So we can say h is equals to square root of s square minus b square over 4. Perfect. So we can substitute that right in. So 1 over 2 b, and then h becomes under root s square minus b square over 4. So now we need to get rid of this s square term because we need our final answer to be in terms of the length of the base. So this is actually nothing but 4 minus b over 2. So we can use this s and then plug that in over here to substitute it. So what would that give us? So 1 over 2b is outside. Then we have a square root of 4 minus b over 2 whole square minus b over 4 square. Okay, so taking this one step further, we would have 1 over 2 square root. We know that a minus b whole square is nothing but a square plus b square minus 2ab. So that would make this 16. I forgot a b here. 16 plus b square over 4 minus 2ab. So the 2's cancel out, so that let me just write it down so we can visualize it. So 2 times 4 times b over 2, and then minus b square over 4. So these two terms right away, we know that they cancel out because one is positive, one is negative. So we're getting closer to the final answer. So 16, these two cancel out, minus 4b. Okay, here we know that in the square root, if I take 4 common, even though this up till here is also correct, but something which we can do to further simplify is if I take 4 common, if I write this as 4 minus b, that is also correct. And based on taking this 4 common, what we can say is that under root of anything times anything, if this is a perfect square, we can actually take it out. So 4 has a perfect square, it's a perfect square of 2, so we can take out 2 from the square root, and that will cancel out with the 2 in the denominator. So we are left with, let me just show that step as well, so that we're all clear. 4 minus b, so this after coming out becomes this 2, and then these two cancel out, and then we're left with b under root of 4 minus b, which is equal to the area. So that's the final answer. Something I'd be careful of, and I made this mistake myself before as well, is when we are calculating the area, I've taken the area of half of the triangle in the past, because when we're doing the Pythagoras, we're only considering, let's say, 1/2 the triangle to find h in terms of another variable. So when I look at that, immediately when I calculate the area, I tend to use the base as b over 2, but since it's the area of the whole triangle, we need to use the base as b overall. So that's just the only thing to be careful about. Okay, let's look at the answer here. In isosceles triangle, this has 2 equal sides. Perfect. So the perimeter is this, and then we represent the perimeter in terms of the length and height. So that's perfect. So that's what we had gotten as well. So hypotenuse equal to h square, b square. Perfect. Okay. So the final answer is actually incorrect in this case, and I think the reason for that is 16 minus 4b. I see. So if you look here, this term should have been negative, because when we're calculating h, which is the height, it's actually the perpendicular term and not the hypotenuse. So that's why this equation is incorrect, and this should have been L squared minus b over 2 squared. So this answer is actually unfortunately incorrect. The height term calculated using the right tall. Let me just make sure I don't misspell that. Theorem should have been square root L squared minus b over 2 squared instead of plus. Because of this error, the final answer is incorrect. Final answer should be area equal to b times square root of 4 minus b. Okay, so I think that's it for this question. We'll mark that as incorrect. Okay, so question 5, how do you find the area of an irregular polygon? Okay, so a polygon is essentially a shape which we can form by combining any number of, let's say, straight lines. You need a minimum of 3 lines because there's no shape you can form by combining just 2 lines, or at least no enclosed shape at least. So how we would go about doing this question is an irregular polygon can be looked at as a regular polygon but with a lot of cutouts. So what's the minimum smallest, let's say, regular polygon? So a regular polygon would be, let's say, a triangle or a square or a rectangle or pentagon. So these are all examples of regular polygons. Regular polygon. But an irregular polygon would be something which is, let's say, made up. So if I have this, for example, this is an irregular polygon. Or if I have, I can even add another cutout in this. If I cut this piece out as well, I get an even more irregular polygon. So the way we would go about solving or getting the areas for these is we need to look at these as regular polygons but with other regular polygons cut out of them. So what I mean by that is, if I look at this exact image above, let me actually, you know what I'm gonna do? I'm gonna draw this shape and then I'm gonna cut out what my final shape looks like. So my shape currently on my irregular polygon right now is this shape. Okay, let me just redraw this final line. So this is my irregular polygon. Now if I wanted to find the area of this, what I can do is I can, let's say if this is A, which is one side of the square which we draw, and this is also A, what I can do is I can look at the area of this polygon. I'm going to quickly shade it in red. So the area of this polygon can be looked at the area of the entire square minus the area of this rectangle or this triangle. So if I subtract this and if I subtract the area of this square here, so essentially what I'm doing is I'm taking the area of the square, so area of polygon equal to area of square minus area of triangle minus area of small square. So that's how we should approach these questions. We need to visualize them as regular polygon first and then look at the cutouts as other regular polygons. In our case it was a triangle cutout and another square cutout here, and then use that to get to the final answer by subtracting the areas respectively. So that's how we would go about this question. I think this text also provides a similar explanation. Let's go through it. We have some, so this is a regular, this is an irregular. So if I look at this, let's say for the triangle example, if I'm given that, if I look at this as my irregular polygon, what I can do is in my mind I can look at this as this, but I can add like a dotted line and then say, oh, this is actually a rectangle, but I've just cut out this triangle from it. So if I subtract the area of the rectangle minus this triangle, I'll get this triangle's area. Stuff like that. Okay, so they've done a similar thing. They've given them a shape with different lengths, and then they have gone ahead and computed the area, which is the area of, in this case they've added it, and then they've subtracted this. That makes sense. So they've added this area plus this area and then subtracted this area, which is correct. Let's just make sure the final answer is correct. 7 times 13 is 91, correct. 15, 6, 30, 15, so that cancels out, so it's 91. Perfect. The solution is correct. Okay, next question, question number 6. Okay, so for this question we'll be proving a trigonometric equation which we're given. So we're given this equation to prove sine of a plus b multiplied by sine of a minus b equal to sine square a minus sine square b. Okay, so to prove this we're gonna start from the left hand side, and right at the back if I look at the two terms on the left hand side, we can see that there is an identity. If we're familiar with, we can start applying that. So the identity basically goes that if we're given sine of a plus minus b, that is equal to nothing but sine a cos b plus minus cos a sine b. Okay, so basically in case this here is a plus, we get another plus, and then if it's a minus in sine, we get a minus. So if we apply that to, if we use that and apply it here, what we can get from that is so applying that we get sine a cos b plus, since the first term is a plus, cos a sine b multiplied by, so the second term now, which is sine a minus b, so this here will be a minus, so sine a cos b minus cos a sine b. So now if we go ahead and multiply the two terms, just expand this. Now if we go ahead and multiply the two terms, we can start multiplying individually first, so it's easier. So this basically becomes, if I take this and multiply it first, what will I get? I'll get my first term as cosine square A cos square B minus sine A cos B cos A sine B. And then for my second term, I'm going to multiply this with this bracket here. And what will I get? I will get plus cos A sine B sine A cos B, and then I will also get minus cos square A sine square B. So if we look at these two terms in the middle here, we can see that they're actually exact same. So this term and the term here, they're the exact same, except they have the terms written down differently, but we know the multiplication is commutative like we just learned, so we can cancel these two terms together since one is a negative and the other one's positive. So if we get rid of those two, what we're left with is essentially sine square A cos square B minus cos square A sine square B. Since we know that the final answer which we need to prove is entirely in terms of sines, we need to get rid of this cos squares. So we know a property which we're familiar with is, so we would think that sine square alpha plus cos square alpha is actually equal to 1. So from here we can say cos square alpha is equal to 1 minus sine square alpha. In this example, it actually becomes sine square A 1 minus cos square, will be 1 minus sine square. And for the angle, it's not alpha, it's B in this case, minus, and then we have a cos square A, which according to this formula becomes 1 minus sine square A times sine square B. So if we do this multiplication, what we would get is we would get sine square A minus sine square A sine square B, and then in this side we would get minus sine square B plus sine square A sine square B. So again, if we look at the expressions, we know that these two terms, the sine square A sine square B terms, are the exact same, and hence they would cancel out, and they have the opposite sign, of course. So these two cancel out, and in the end we're just left with the two signs, and we're just left with sine square A minus sine square B, which is equal to right hand side. Therefore, hence proof. So we were required to prove that this is equal to the right hand side, and we just did. So let's see what this solution says. Okay, to prove we will use the angle sum and difference identity. Perfect. Based on that, we expand this, then we multiply all the terms. We're left with this. When they cancel out, we substitute for cos square. It's correct, and then we cancel out. Perfect. The solution is correct. Okay, next up. Question 7. what is the multiplication property of equality? Okay. So if I have an equality, which is any expression equal to another expression, if I multiply anything on one side, I will need to multiply it on the other side as well. Only then those two terms will remain the same. That's kind of how equality works in general. If you do an operation on one side, you need to do it on the other side as well to maintain the relationship. So essentially, the multiplication property of equality states that if I have an expression A is equals to B, if I multiply anything on this side, I will need to multiply the same thing on the B side as well in order to maintain the equality. So if I multiply, let's say, both sides by 2, I would get 2A equal to 2B, because 2A is not equal to just B. As we know, A is actually equal to B. So that's a simple explanation for this property, is that if you see an equality and if you multiply anything on one side, you need to multiply it on the other side as well in order for the equality to hold true. So A equals to B, then A is saying that both sides of the equation to begin with, like they're twins, multiply one side by an equation, the other side must be multiplied by the same thing. So exactly what we did, we had A equal to B, and then our C is actually equal to 2, then we need to multiply it on both sides. So this solution is correct. Great explanation, and the answer is correct. Okay, next up. How do you convert 3.125 into a fraction and into a percent? Okay, so 3.125 into two things. We need a fraction into an A over B form and then into a percentage form. So let's do the percentage first. So the way you convert any given number by a percent is you multiply it by 100%. So in your mind, you should already know that this number, since it's greater than 1, you would get a percentage which is greater than 100%, because essentially 1 represents 100% and then 0 represents 0%. So any number between this would fall between 0 and 100%, and any number above that would be greater than 100%. So 3.125 times 100 makes it into a percent. So we would get 3 2.5%. Okay, and then for the fraction, the way I usually do fraction questions is I look at the decimal and I get rid of the decimal. So if I get rid of this decimal, we would be left with, since there were 3 terms behind the decimal, we would have to divide by 1000. Or the other way of looking at it is if I have 3.125 and if I multiply and divide this expression by 1000, we would be left with 3125 divided by 1000. Okay, so we can convert this in a simpler form by using division. So we know that if I divide this expression by 5, I can continue to divide this. So let's see. So 5, 200 is 1000, and then 5 times 6 is 30, then 2 is 10, then 5. So we're given 625 over 200. Now this can still be further divided, so let's go ahead and do that. So 5 times 40, and then this is 125. Again, 125 over 40 is still divisible by 5, so we are left with 8 here, and then this is 25. So our final answer is 25 over 8. So for percentages, you multiply it by 100, and the final answer is your percent. And then for fractions, or for decimals, just get rid of the decimal points, divide that number by that many zeros followed by a 1, so that many hundreds or tens or thousands, as there are decimal numbers behind the decimal, and then just keep dividing till you get the fraction in the simplest form. Okay, perfect. And then if we wanted to write it as a mixed fraction as well, we would divide 25 by 8. So 25 threes is 24, and the remainder is 1. So we're left with 3, 1 over 8. So let's quickly look at this solution. To express the givenness, we multiply a number by 100%. We're given this. Decimal 1000 place means that we can divide. It's perfect. Okay, next up. So since we were just on the topic of fractions, this question is asking for an explanation or some clarification on what a numerator and a denominator is. So if I have any number in terms of fraction, so question 9, if a fraction is a over b, we just write it like this. So the number on top is the numerator, and then the number at the bottom is the denominator. So if I'm given an expression 5 over 7, this is the numerator, this is the denominator, and so on. So in the definition would be something that the numerator would be the upper term in a fraction, is called the numerator, and then the divisor is, or the term below the fraction, is called the denominator. So the numerator is the upper number in a fraction, while the denominator is the lower number. For example, the fraction, the number 5 here is the numerator, while the number 7 is it. So this is correct. Okay, question number 10. How do you find the area of a triangle? So the area of triangle actually can be found in multiple ways. The most common way, which we also have covered recently, was using the base and the height, but there are other ways to find the area. So let's cover them. Question 10. Area of a triangle. So the first way is using base and height. So the formula for that is half times base into height gives the area of a triangle. So if I'm given a triangle here, this is the height and then this is the base. If I multiply half times the base and height, I get the area of the triangle. There are two other ways as well. The second way is using an angle. So if I'm given one side and an angle enclosed by the triangle, so in this case, if I'm given this is, let's say, an angle theta, and I'm given these sides A, B, C, let's say. If I drop a line perpendicular here, I know that this is the height, but I can't express it in any terms. So let's say if I wanted to express it in terms of A, we know that the sine of an angle is the perpendicular divided by its hypotenuse. So I would say sine theta would be equal to perpendicular upon hypotenuse, which in our case is h, which is the perpendicular. So h over A. Now we know that we need to calculate the area, but we don't know the height. It wasn't given to us, but we knew the angle. So if I get h in terms of A and the angle, we should be fine. So h equal to A sine theta. And then from that, we can say, using the same equation, half into base into height. Our base is B, which we're given, and the height is A of sine theta. So that's the second way. And then the third way is actually using the coordinates of the triangle. So if I'm given a point A, B, and C, or actually it's using the length of the triangle. If I'm given these 3 points, then the area is actually given by this formula here. So the area is given by S times S minus A times S minus B times S minus C, where S is equals to A plus B plus C divided by 2. So this is also known as the Heron's formula. Now it's critical to note that this here is actually using A, B, and C as the sides. So those are the lengths of the sides which we have been provided, and we're using those to calculate the area of the triangle. This can also be proven through trigonometry, but in our case we will just use the Heron's formula to get the answer. So this solution here does outline all of the 3 ways to calculate the area. So the solution is correct. Alright. Question 11. What is an isosceles triangle? So an isosceles triangle is a triangle which has any two of the sides of the exact same length. So if I were to draw a triangle here, and if I know for a fact that this length, let's say, is equals to 8 centimeters and B is also equal to 8 centimeters, I can say that this triangle is an isosceles triangle. An equilateral triangle will be a triangle where all 3 sides are equal. So we need to know the difference between the two. So if I was also given a C equal to 8 centimeters, I would call this triangle an equilateral triangle. But let's say, for example, if C is 10 centimeters, we know that it's not equal to A and B, so we'll consider this as an isosceles triangle. So isosceles triangle having 2 congruent or equal sides. Okay, so the answer is All right. So area of a sector. Okay. So this is kind of a fun question because we can relate it to pizzas, and pizzas are obviously fun. So what is a sector? So if I have a circle, and if I cut it into a small pie, what I'm left with is actually a sector. So if I have the circle here, and let's consider this as the midpoint, and if someone eats a piece out of this pie or pizza, um, this portion is actually considered as a sector. Okay, so let's say if I take this out now and put it on that plate, and I'm like, hey, what is the area of this sector, or is this slice of pizza that I'm having? So our pizza would be of an angle theta, or slice. Then we know that this whole pizza had a radius of r. So to get the area of the sector, we need to quickly revisit what the area of a circle is. So the area of a circle is nothing but pi r square. However, in reality, we can look at the area of the circle as nothing but the overall angle, which is 360 degrees. So 360 and then theta. So in reality, this is the area of the circle. We have theta, which is the angle. In a complete circle, since we go 360 degrees about the center, we say our theta is equal to 360 degrees. However, in the case of the sector, that's not the case. The theta would be different, and if I plug that in, that is the formula for the area of a sector. Okay, just as a quick note, where theta, let's say, is not equal to 360 degrees. Now, for a semicircle, if I was given this question and asked, okay, what's the area of a semicircle? So a semicircle is also considered as a sector, and since I'm going 180 degrees around my center point, I would say that my area would be, you substitute 180 here and you get pi r square over 2, which is correct, which is the area of a semicircle. So to conclude, area of sector is equals to theta over 360 degrees pi r square. And if I want to write it in terms of radians, I know that 360 degrees is nothing but 2 pi radians. So over 2 pi times pi r square, and then the pi's cancel out, is nothing but half and theta r square, where theta is in radians. Okay, let's quickly verify this. Area enclosed by a circle of given r, a is equals to pi r square, and then 360 degrees equal to 2 pi. So if we take, they're taking the ratio, which is also correct, we get area of a sector equals to pi r square theta. So that's perfect. Okay, I think we're just about at the end of the lecture. So I hope you guys followed along well. If you have any more questions, feel free to check out the link in the description. You can reach out to us and we'll most likely get back to you as soon as we can. And then please feel free to like, comment, or subscribe to the channel. Thank you so much. This has been Nehel, and have a nice day. Bye bye.